Hello, this is Dr. Lukes, and this is the solution to exam 3. So now let's look at question 2. In this one, the first question asks us to find the relative humidity, or when the relative humidity is 20%. We want to find the equilibrium moisture content of the entering air as a mass fraction. So this means we want to find W. We're not looking for capital X, we're looking for W. Now my graph provides for me X, and I read X star as 0.07 or 7 kilograms of water per 100 kilograms of dry pasta. To get W at equilibrium, I'm simply going to use the fact that this is per kilogram of dry pasta, so I have 1.07 kilograms of wet pasta. And so therefore 0.065 kilograms of water per kilogram of wet pasta, however you want to call that. The second part, and sorry, I had taken a question out in between here that probably would have been made this a little bit clearer for you, and I apologize for that. But this says that the recipe calls for 50 kilograms of dry solids. And so what's the mass of pasta at the beginning of the drying process? And in that case, we need to know that initially it had a moisture content of 0.31 kilograms of water per kilogram of dry pasta. And so the amount of water is going to be 0.31 kilograms of water per kilogram of dry. And then I'm going to multiply that times my 50 kilograms of dry. Therefore, I'm adding 15.5 kilograms of water to these solids, and so the mass of pasta initially is going to be 50 plus 15.5 is 65.5 kilograms of pasta. The next question, okay, we have a 1 pound box of pasta that has 20 noodles in it, and in that there are 0.4 kilograms of dry solids. So this is the L sub S, the dry solid mass. Each noodle covers an area of 200 centimeters squared, so you might think of that like a blanket covers the area. And so 200 centimeters squared is the area that it covers. And I have 20 of those. If the lasagna noodles are laid out on a screen so that drying occurs on both sides, so therefore I want to multiply this times 2 because I have both sides. And so I end up with, 8,000 square centimeters, or 0.8 square meters, is the surface area of these noodles in total. Okay? And we're asked to find the rate of drying during the constant rate period. So in this particular case, the rate formula, the definition of rate, is LS over A delta X over delta T, and that is X the moisture content. L sub S is given as 0.4 kilograms. That's my total dry solids. The surface area is 0.8 meters squared. Delta X, well, I can only apply this to the constant rate period. So during the constant rate period, it starts at 0.31 kilograms of water per kilogram of dry pasta, and it ends at 0.25 kilograms of water per kilogram dry pasta. And you could have converted these over to free moisture contents, but because you're subtracting, it really doesn't matter. Now delta T was given up above. And so delta T was 4 hours that this drying occurred. And so if I do this, this was dry pasta, those units cancel. I end up with the rate during the constant period is 0.0075 kilograms of water per hour per square meter. Now the last part here, I'll work with whatever number you came up with for R in the previous part. I did not give you another one because I was really not wanting to give you hints on the units. So that was my rationale for that. But if you work with the rate equation, you can do it from the energy balance point of view, and that involves the heat transfer coefficient. And this is that formula.